Hi, today I'm going to show demo Fortran programming in our RacEr GPU. In that, I'm going to show you how to call a Fortran program or Fortran function in our GPU kernel. So before I'd like to proceed on showing a demo, I'd like to give how to use our products in a cloud. So those who are not familiar with that in a cloud computing, so just I'll go through that how to use F1 instances. On the right side, you can see that you just need to register or create account in AWS. You just go to this link, https aws.com console and register. Then once you do that, in the search panel you go search in search panel you type AWS Marketplace, and then you select FPGA developer AMI, and then it will give a lot of options. Then you go for F1 to X large. So after selecting storage and IP protocol and so forth, and then you create instance. So and then once you have instance, then you can connect either SSH or PuTTY. Once you connected SSH or PuTTY, and assuming that you have loaded our FPGA image and the programming model, then the next step is running any applications. So our RacEr GPU or any of our products, either it's a Falcon or Supersonic or a TEDS, all of have a Vivid compiler. So Vivid compiler is a flavor of I would say C Fortran on the back end. And then on top of that, you can run Python, PyTorch, or CUDA-like programming, anything on that part. It can also support OpenGL or OpenCL. So in this demo today, what I'm going to do is I'm just going to run a sample of floating point addition here. I'm going to call a Fortran function on our GPU and then compare the results with in x86 machine. Okay, so just want to assuming that you have loaded, as I mentioned, you have loaded F1 instance connected through PuTTY and loaded our FPGA image. And then I'll go through that how to call our functions and run applications. So what I'm going to do is, so this is a sample program and number F90. So this is a sample program. So here I'm calling passing two arguments A and B, and then adding A and B, and then it's add equal to A plus B. We'll call that this Fortran program function. So in order to call this, we have to register this function in our kernel. So this is in kernel vector C. So as you can see that we have to declare just to let you know the compiler that this is an external function call. So whatever we call, we have to add underscore for any Fortran functions call, add underscore here. Then I'm passing two arguments of double, and then once you add that, once declared it, then we call Fortran function here on the C result. So C result here, I'm calling add underscore Fortran functions, the program what I've shown you previously, and then this one, the C result, will pass to our main kernel x86 machine. Okay, so this is the one. Then what you have to do after that, you just need to type in our programming model, just type make regression, so it will pass the test. So I'll show you the main file here, which one to the to compare x86 with x86 results with our Fortran program results. Okay. So this is the main file. So in the main file, this is the x86 result. So this is a function call. So C is equal to A plus B, and this is a matrix. And in the kernel, you have to first define uh, path to binary, initialize the device, and the load binary and unfreeze the tiles. So this is basically a initialization process, and then I have to allocate memory for ABC matrices, and then allocate memory for on the host as well for the matrices. Then you create a random numbers. So you can see that I have created random numbers for A host and B host here. Then I copy the results from host to the DRAM memory. So this is how we copy it. So this is the A host results copied here, source and destination, and B host results here, source and destination, destination and source here, and then so initialize C value device to the 0. Then you define the block size, number of block size, and then initialize tile group, and then enqueue the with tile groups and so forth. And then what the final, I'll jump into the final part here. Okay, so this one, so calculate the expected result and the compare. So this is the x86 result, and then the C host is from the uh, result from the PCI slot. So then we are just comparing here. So we have a tolerance of F error here. So and the ratio of the order of 10 to minus 7. Okay. Yeah. So the results has passed. All right. So yeah. So that's it. So if you have any questions, please do get back to me or send us an email. Thank you.